Hey everyone, my name is Miguel, and today we'll talk about PyTorch and TensorFlow, which are some of the most popular frameworks to develop deep learning models. And we'll talk a little bit about their applications, but mostly about their features and how they compare against each other. So even though these are open source, meaning you can download them freely on your computer, I was surprised to find out that they were developed by huge companies, starting off in 2015 when Google launched TensorFlow. More specifically, it was Google Brain's team that developed it. And shortly after this, in 2016, then came Meta with PyTorch. More specifically, it was Facebook's AI research group that developed it. So what have been some popular applications over the years? For PyTorch, these include Stable Diffusion, which is an AI image generator, and we have talked a little bit during classes about it. Also, OpenAI's Whisper, where OpenAI have developed ChatGPT, and also Tesla's Autopilot. Now, keep these brands and names in mind, and let's compare them against TensorFlow applications, which include Twitter, that has used it to store tweets by relevance, also Spotify, that has used it for their recommender algorithm, or PayPal, that has used it for fraud detection. So do you see any trend between these and the previous? If not, I'm trying to hint at that these seem to be bigger companies, whereas here, more startup, kind of, more innovative. So the trend over the years has been that PyTorch has been exactly more innovative, more catered towards academia, whereas TensorFlow has been more industry focused. And to further prove this point, we can also look at data from Google Trends, for example. At the beginning, when these were launched in 2015, for example, we see that TensorFlow, denoted by the blue line, was actually more popular. It quickly gained traction. But if we go to current date, we actually see that the red line, PyTorch, has become more popular. So we could maybe even see that this academia versus industry line will be kind of erased. And to also expand on this argument, we can look into papers with code, for example, where the reddish area is PyTorch and the orangish is TensorFlow. At the beginning, again, we have more TensorFlow papers with code, but as time went on, there's a greater popularity of PyTorch. This could mean that more academia is using PyTorch, but it also could mean that it's simply getting more traction and becoming more popular. So we'll have to see. But this to say that both have been extremely popular over the years. So what do these frameworks actually go about? What do they consist of? I'm going to speak in analogies, and we can think of PyTorch as Lego blocks, where they are single code blocks, or single blocks, in this case, single units of code that can be very personalizable. You can mold them as you wish to create very creative models. Whereas TensorFlow is more like Tinkertoy, or Kinix is another brand, where you have these pre-built little blocks, and you can create kind of pre-built figures, as you see in the image. You kind of have your instruction manual, and you can build these type of structures. This could allow you to, yes, create structures very quickly, but not as personalized as Lego blocks or PyTorch. So another way to think about it, if we think in a slogan, I would say that PyTorch is more of a flexible, creative researcher, whereas TensorFlow is the model deployer, meaning that it's also super used within the community of machine learning operations, or MLOps, especially to deploy models. It has a wide ecosystem. So again, PyTorch, the flexible researcher, and TensorFlow, the model deployer, or the model builder. So some additional points of comparison could include runtime and memory use, which is better. We actually see from the literature that both perform very similar. Some models may perform better in one or another, but they're roughly on par. In terms of debugging, if we follow the analogy of Lego blocks versus Kinix or whatnot, we also have that PyTorch is somewhat easier because you have single blocks of code that you can break down. In terms of programming languages, both are very Pythonic or Python focused, but TensorFlow also has integration with C++ or JavaScript, so TensorFlow would have the upper hand. In terms of trending, we already saw Google Trends and papers with code. PyTorch is actually winning here. In terms of community, both are super active, wide communities, a lot of participation, so both are on par there. In terms of ecosystem, which has better integration with other programs, other APIs, TensorFlow actually has a better integration there, or a better community because it's industry focused, and easy to learn. Here, it's where it gets tricky. PyTorch generally has the upper hand, but we also have to talk about TensorFlow. It would make sense to say that, yeah, PyTorch being Lego it's easier. It's easier to understand because there are single blocks or single units of code that you can break down and learn. Whereas TensorFlow, there are more complex figures. You would have to read the instruction manual and so on and so forth. But there is something I had neglected to say, which is that TensorFlow has great integrations. This relates to that it has a better ecosystem. It's industry focused. In this regard, it has TensorBoard, which is great for visualizations if you want to fine tune a model, but especially it has a Keras integration, which is built on top of TensorFlow, and it's basically model development for beginners. Very simple syntax, very straightforward, slightly quicker, and it's great for prototyping. So in this case, we'll actually be able to run a sample model, and we will be based off of Keras's own featured works. So for example, if we literally go to keras.io, and they have a ton of examples which we have been seeing throughout the course and talking a little bit about. For example, they have image classification, which is a great deal. They also have time series analysis, and in this case, we'll focus on an English to Spanish translation using a sequence-to-sequence transformer. And not to get into the details, but you can find the code, you can actually run it. And spoiler alert, if you want to install any of this on your computer, it can be somewhat tricky. It happened to me. So in this case, I used it on Google Colab. So again, this is basically an English to Spanish translation. And what it does, one, you can download the data. It's going to clean it up. It's going to build the model. And in this case, we trained it during 5 epochs. It should be at least 30, but in the interest of time, because it would have taken like 30 hours, if not, only 5. And if we have a translation here, for example, here in quotation marks, we are going to indicate some sentence. John ate his pizza, which in Spanish should translate roughly to John se comió su pizza. And let's see what the model renders. And actually, it is 100% what you would have to say. John se comió su pizza. And if we go through another one, we can say John pet his dog. Let's see what this yields. John a su perro. Yep, and we're missing a word here. So this is part of the setbacks that we did not train it that much because we have an accuracy of 63% approximately, 64. So yes, this means that it is not perfect. If we trained it more, probably get better results. But basically, this I just want to say that it performed quite well. And the invitation is to go to Keras, and you can run very simple models and with quite interesting results. So with that extremely brief overview of PyTorch and TensorFlow, what would be a suggestion or a takeaway? So for one, again, PyTorch is very flexible. It's great for innovation. You can personalize your code a ton. So it's more catered towards research and being, again, innovative, whereas TensorFlow, more industry focused. You can deploy models at scale and relatively quickly. So with all that said and done, the general suggestion is if you're more into academia, want these highly flexible chunks of code or models, PyTorch. If you're more in the industry side, you want something that is already built and that is scalable and reliable, you can opt for TensorFlow. And if you're relatively a beginner or just starting off, Keras, which is again is built on TensorFlow, you can use that. But as always, the huge disclaimer is that choosing between both frameworks should vary according to your use case. It's very specific, and as we see that PyTorch is gaining more popularity, the industry versus academia trend may not hold up. So it's always worthwhile keeping abreast of both, staying active in the community, and seeing where the trend goes. And with that, thank you for your time. I highly invite you again to read on these topics. They are so deep. I'm sorry I could not touch on them more. There are these great videos on YouTube that I took some inspiration on, the TensorFlow in 100 seconds or the PyTorch in 100 seconds if you want to get a quick grasp of both of them. There are a ton of blog posts and videos that are just debating between both, and they basically share what I've talked about, the academia versus research, the ecosystem and the community, and so on and so forth. So again, I invite you to read on it. Go to Keras and experiment with models, or TensorFlow or PyTorch. And thank you very much. Let me know if you have any other questions, and looking forward to the discussion. Thank you very much.